real job that you will be doing. Let's say yesterday I was explaining to you guys, if you are able to see my screen. Yeah, importing the library, we are done. Importing the data set, we are done. Splitting the data set into training set and test set. This we already know from pre-processing cleanup. From the first three steps, there is nothing that you don't know. You already know the data science part of it, right? So you can understand this one. Now, yesterday the problem statement that I was giving to you is what? The problem statement is based on the year of experience, there are salaries that are being decided for the people. What is the salary being decided? For year 1.1, the salary has been decided to 39,000 something, and 1.3 46,000 something, blah blah blah. So all this is in the data set. Now here is the important point coming up for the linear regression. So the next three lines in the step number 4, training the simple linear regression model on the training set. So what is the training set means? You already know how to split the training set and test set. You will train the whole model on the training set, and how much percentage that I'm taking? 80% of the data will go to 80% of the data will go to the training of the system, and 2% of the data or 20% of the data will go to the test set. But if I will open up this file which is available to me, this is the file that I'm talking about. The file is what? Anybody know what is CSV file is? Comma separated file. I'm not going to repeat that. This is the salary, this is the years of experience and salary file. So if I'll provide you this file, right, you will be able to upload it to your Google Collaboratory. Yes, when you open up the Google Collaboratory, you will be able to do that. So let's do this together. I'm going to email this file to you guys in a shorthand. Okay, so let's do this in a moment. I'm going to send it to you on the course messages section. So here I go. I'm going in the course messages section, sending you 2 files which I'm going to provide you very quickly. Create message. Salary data. So I have just sent you guys the salary underscore data.csv file in the course messages section. Everyone will have it. Okay. Next file that I want is this IPYNB file. See this IPYNB file? You don't have it, so I will give it to you as well in a very quick succession. Please download that file that I've shown it to you on your computer. And I'm going to send you in the next file, which is IPYNB file. You are able to get that file as well. So you guys have two files. Let me go to my Google Collaboratory and you guys will go to your Google Collaboratory. Okay. And let's see, work on it together. I will be able to do that. So let me go to my Google Colab. I go to Google Colab, and on the Google Collaboratory, I'm just going there now. Everybody know how to go to Google Colab? Next thing that I'm going to do, you guys have got two files from me. One is IPYNB file. The other one that you got is the salary_data.csv file. So let's go here, click on upload. I'm sure you have downloaded both files. They are sitting in your download folder. Go to browse and upload which file? I'm going to upload IPYNB file. I'm going to upload simple linear regression IPYNB file. I'm going to upload that. It's going to be uploaded right now. Okay. The reason it says is because I need to log in with a different account. So I'm going to upload, browse, and I'm going to upload that IPYNB file which I have given to you. It might be a different name, but that's fine. Simple linear regression.ipynb file. What is the file name that you have? Same? Okay. So now it's getting uploaded. In a flash, it got uploaded for me. Any questions so far? Are you guys able to upload that file? Okay. Are you seeing the code? Just like me, just like on my screen. We know how to import libraries. We know how to import the data set. The data set is what? Salary_data.csv. Have we uploaded the salary data.csv yet? No. Where we need to go? Click on this folder. Click on file. I think this one, and it will show upload button. And when I say upload button, I'm going to upload this salary_data.csv file. Ignore this warning, and we are good. Okay. Any questions? No? Let's start playing. Importing the libraries. Play button. Done. Importing the data set. We all know this, how it works. Splitting the data set into training set and test set. I have already explained this when I was explaining the pre-processing. Any question? I will check that. Oh, mine is okay. Have you uploaded the file? Yeah, just run 1, 2, 3 again one more time. Splitting the data set into training set and test set. Done. Now, here is the model. Remember that model of potato that I was mentioning? That linear regression model. So we are going to train our model. Hey, model, this is the point I want to explain. From here onwards, I need to explain everything. Step 1, 2, and 3 you already know. Step 4 I want to explain. In step 4, what we are doing, we are going to the scikit-learn library and saying, I want to import linear regression. By this time, everybody know what import does. Import is bringing the APIs of Python scikit-learn library. And then I am initiating a variable or a instance of the linear regression model. What is the name of that? Regressor. I can name it R, I can name it anything. The name of that is regressor is equals to linear regression, bracket open, bracket close. Now, what I wanted to know, what I wanted to train in the third line is that regressor dot fit. So regressor will learn everything using the fit method of this model and train itself. So let me run this part. First line, second line are easy. In the section number 4, training the simple linear regression model on the training set. We are not training it on the test set. Test set is for us. So let's see if I am going to say I want to run this model, what will happen? It has trained the regressor now. Regressor is now trained on this model. Predicting the test result on it. Okay, so let's say what will be that? So x. So if I wanted to see what is in x and what is in x and what is in y, let's look at that in a moment. If I want to add a code, can I do it? Print x underscore train. Can I do that? X underscore train. Let's do that and print it. This is the training set. This is the x train. I wanted to see the y train as well. For each individual line, for each individual, we have an x train and we have a y train. So I can say add a code here. Print y underscore train. Let's do that. And it is training. This is the y training set that we have. So we are just seeing the split of the data. That's about it. I'm sure if I search this y train, I will be able to find this out in a moment in a flash. So let's see, Control C. If I go to this Excel file, salary data.csv, these are the salaries of the people. And if I'll say Control F, Control V, this guy with the 2.9 years of experience is a part of the training set, right? I just randomly picked up one guy and checked it. Who is the part of the test set? Let's look at that. Can we check that? We'll go to the code and say print y underscore test. And we can see who is the part of the test set. Let's see how many people. These are all the part of the y test. If I want to print x underscore test, I can print that as well. But let's see who is this guy. 55794, 55,794. So as you can see, if I go this way and go to salary, Control F, Control V, find what is happening. This guy with the 4 years of experience with the salary of $55,794 is a part of our training set. So we know that for a 4 years of experience, there are 2 variations in the salary. What is the first variation? 55,794, and for a 4-year experience, there is a salary of 56,957. So our model is getting trained on that, and there are some salaries that are part of the training set. There are some salaries and year of experience that are the part of the test set. So let's look at that. Keep moving forward. Our model is being trained now. Let's say I want to predict that what is model is predicting. So let's look at this. I want to predict that if I'll provide you the test set, can you give me the salary based on what you have been trained on? And let's look at that. Y prediction. Let's click on Y prediction, and Y prediction is now ready. Let's say what is the value of print Y underscore pred. So if I print Y pred, it is going to predict the salaries, but we don't know what is the X associated with it. So let's print out the X test as well. Print X underscore test. And if I print this now and play it, now here's the spelling mistake, X underscore with a capital X. Now look at this, guys. I want you to look at the mapping. For a 1.5 years of experience, the prediction is that his salary would be 40,835. So this is the, based on the training that we did, model predicted that any person who has a 1.5 years of experience, model predicted that he will have a salary of 40,000. Does that fall in a range? Let's look at that. 1.5 years of experience. Let's look at that. Probably ballpark figure is good. What is the 1.5 years of experience saying? 1.5 years of experience in the actual is saying what? The salary will be 37,731. Model is predicting based on the training set, saying that 1.5 was not the part of my training, but I can predict that the salary of that person will be 40,835, which is a little bit above what the actual salary is. So you understand what is the difference between actual versus prediction. You train the model, you did not give it 1.5, but based on its training, it realized that the salary will be. So this is where the computer is thinking now. Computer is thinking now based on the linear regression model, that how you will be paying a person with a 1.5 years of salary. And if I am the owner of the company, I will be paying what? Not the predicted salary. I'm a cunning guy. I will pay 37,700 because I don't want to pay my employees more. So prediction versus what your model is saying, you will always want to be paying less to your employees. So if I'm able to find out, if you are a 10 years of experience and you come to the, hey, I have 10 years of experience, I want 100,000 of it. Hold on, let me train my model and I'll find out what the people in this field are earning with this much experience. You will say they are earning maybe 100K or 200K, whatever they are earning. If he comes and say, hey, I want 100K in my salary, I will come back and give him an offer based on the regression model. I will come back and say that I will only pay you 80,000 because I already know my numbers and crush them based on the regression model. So that is why regression is able to give you that this is what you are predicting versus. And remember, 1.5 was not the part of training. 1.5 was the part of the test. We never showed computer 1.5. We showed computer 1.1. We showed computer 1.3. We did not show 1.5 to the computer because remember, 80% went to the training, 20% went to the test. We are asking for the test set. What is the, so anybody who has 10.3 years of experience, how much is the salary predicted? 123,079. Let's see what the model is saying. Scroll down. 10.3. What is the salary? 122,000. Model predicted 123. Pretty close. 102. So I can probably hire this guy. Right? Because based on his experience, he's asking me how much. So data is now talking to me instead of me asking the. So I'm asking the data instead of me making a wild guesses. Last part is, which is the interesting part, which I don't do too much because it's not my nature, but I will see visualization part of the visualization of the training set and test set. Look at the graph. and I don't do too much of this, so I'm not able to explain too much about it. But look at the picture. This is the coding part, which I'm not going to be explaining very good. But you can see you are drawing, you are creating a scatter plot with the red dots on the screen. The middle line is the line that your regression model has predicted based on the training. It is saying that if this salary, if you look at this salary, it is here. The actual salary it will predict is somewhere here on this line. This is the best possible line that can go through center of all these points. And again, this is the best possible line that it can go through for the training set, for the test set. But I'm not going to explain you the visualization part. Do you understand this part? So what if I want to give it a salary of something that is not in the test set? Let's say I have an experience and I want my model to predict. So let's say if I have a 5 years of experience, I want my model to say what salary should I give. If I click on this, it is able to give me that value. With the 5 years experience, you should demand 73,545. Even though this value is not available in the training set, this value is not available in the test set, but I am able to give it a hard coded constant value which is not available in that Excel file. I am still able to ask it, can you predict what will be the salary of a person with the 5 years of experience? So let's click on this and check around. Is the 5 is here at all? No, 5 is not here at all. But you see, based on the model prediction, 5-year salary will be around 70 something thousand, whatever is predicting. I don't remember the number now. 73,545. So model is not actually very good. It's a linear regression model, but it is giving me the answer based on whatever the training is. Okay, so now my question to you guys, the more data that I will give it to the training, the more data, millions of rows. These are just how many? How many people are there? There are only 30 people in this. If I'll give millions of data, will the accuracy of my model will increase or decrease? Increase. Very definite answer. With the 31 people, it can only predict so much. But if I'll collect the whole data from Statistics Canada and run that kind of a data, I will have a lot more accurate numbers. Thank you.